Welcome to Poppy's workshop. This is Poppy's last stab at acquiring the filthy lucre. Take one. Here is the idea I had. Hey! It works. Okay, here's the idea I had. I stick a laser in the spindle of my shear line, right? And, 12 inches away, the dot. Little problems here. Not big enough to jam in. Could be overcome. It's off center. See that? It's off center. Well, if I rotate it, the spindle while it's in, right? It would circle. X marks the spot. No good. So I got looking on the internet. I looked for all kinds of things. I looked for one moment. The pharmacy guy is here. Oh! Damn it. Okay. I'm back. That was the pharmacy delivery guy. Okay, so that's no good. So I looked all over the internet for all kinds of things, for laser pointers, nice ones, and they all seem, no, they won't work. I said, laser sighters. So, I look and I see all kinds of laser sighters. I mean, I see little bore sighters stick in the chamber of your gun. It shoots the laser out the barrel. I said, well, I don't want to stick one of them here. Maybe the kaleidoscope effect going down the barrel. Get the .22 caliber and make an adapter to attach it here. But they all said 1.5 inch red dot at 100 yards. And somehow the math, it didn't work right. I saw some that were focusable, right? Didn't seem like they would get tight. I want 1/1000th of an inch diameter red dot. That's 12 inches here between my fingers. Yeah, right? From where it comes out the laser to where X marks the spot, 12 inches, all right? 1/1000th of an inch diameter red dot right here where the X is. Every machine shop in the world wants one of them, right? Don't tell me you don't. You yeah, you sitting out there in YouTube land, you want this device where you can put that 1/1000th of an inch diameter red dot where X marks the spot from 12 inches away. Bridgeport milling machine, jig borer, jig grinder. Yeah, no more wiggler for X marks the spot or on the edge. No more guessing, did it wiggle or plop? 1/1000th of an inch diameter red dot right. I can't get go right where X marks the spot, because X marks the spot is right here where the cursor is. Anyway, here's X marks the spot from 12 inches. And I saw one. Yeah, here it is. A boresighter for 17 caliber to 50 caliber. In other words, BB guns to machine guns. Okay. And it comes with these rubber adapters for the various sizes. They're slit and they got screws and they expand. Don't look at that stuff right now. That's unimportant. That's later on down the road. Anyway. First I put the 9mm adapter on. And come on, baby. Come on. You disobedient thing, you. Somehow it changed dimension. Come on. Gonna start now? Yeah, you are. You changed the dimension a little bit. Put the pin back in. Oh, come on, you. Put it in from here. Now. That's an adapter I made really quick and dirty, because the 9mm wouldn't slide all the way in because it hit either this screw head or the screw head holding, or I should say this, either the other end of this screw or the other end of the screw holding this pulley on. So it wouldn't go through. I had to make this thing. Cheap, quick, dirty, plastic. I'm going to take these. Piece out of an old radio. The string from the tuner to the dial went here. I'm not sure what this came out of, but it's got a nice taper. Turn this down. Put this here. It's a 2mm thread. Now, my theory is I got a taper here. I got a taper here. I got a spring here. this flange right here is gone. This rounded part acts like, you know, it pulls in a reverse of the turning between centers principle. Or I'm applying the turning between centers in a strange new way. Anyway, that's how I plan to attach this one here. The reason I know that screw, which goes in here, is a 2mm, as I checked. I used Machinery's Handbook, I used Metrology, and finally I dug out a cheap watchmaker's thread plate. There's one of them. Come on, you. Hold still and behave. Okay. 2mm. The closest thread pitch I could find, and it wouldn't fit, was 60 threads per inch. All I know is I have I do believe that's the 2mm. Yeah, that's the 2mm. So I can tap that piece of brass and put the screw in. I had another idea. Take one of the screws, machine inside this collet here, so this goes in, clicks in, and will adjust angularly, adjust its angle a little bit to, and then I'd have to turn it down so it could go through here. And then the spring, and I was going to figure out how to do the crossbar and tensioner. I don't know if I'm going to do that. Maybe as a demonstration of something I've got in the works. Anyway, so I had the idea. Where are you? Confine the beam. Okay. 50 micron hole. You can just barely see it. The best way to see it is put in front of a light. There we are, see that? 50 micron, right? Come on, where are you? Not quite 12 inches. And you see it's way fat, very dim. But I did get reduction in the size of the spot. So, concept, well, the concept was, you know, all those pointers with stars and happy faces and all kinds of stuff they screw on. Why not a simple aperture? Guy said 50 micron. I said, 50 microns, 12 inches. Depending on the angular containment on the beam, right? Angular confinement, angular containment. How coherent is that damn beam of light? Then you saw how dim it was. There we go. You saw how dim that 1 milliwatt red was. Ta-da! By federal law, you gotta have a key to turn it on and off. 5 milliwatt. Green. Very bright. This is where the starfield was screwed in, or inserted so it could be screwed on. Here is the focus. Sloppy threads, very sloppy threads. But 5 times the power. Serendipity. It drops right in, almost like it was designed for it. Wow, look at that. Still too fat, but you can see it, and that's 12 inches. So 5 milliwatt red. Why red, you say? Because the red dot is less likely to hurt people's eyes. Green and the blue-violet are more energetic, more likely to cause injury from the quick accidental flash. 5 milliwatt because you saw the difference going through. Did you? Yeah, you did. You saw the difference in the brightness, and you saw I got definite signs of reduction there, right? Too far away. This is very dangerous here. I'd have my laser safety glasses on, but I can't see what I'm doing up here real close. Okay, now. Right on. See? Small, dim. About 12 inches. Too small. Put that in here. This baby cost me 11 bucks. Precision manufactured 50 micron pinhole. When I'm done with this laser work, I might try it for my cold extract coffee process. Been wanting to make one of them. Currently, I think that I need focus that don't wobble, good focus that don't wobble, and 50 micron with good focus that doesn't wobble. 50 micron should give me 1/1000th of an inch diameter red dot here where X marks the spot from 12 inches. I still want it red. Disarm this. Right. Where's a piece of metal? Ooh, yes. Is that actually safe? Okay, that's on. Gee, when I tried it with a different piece of metal last night, it worked. It might actually be safe. You might actually have to have this key for safety. Oh, now someone is going to post a video to YouTube showing exactly how to bypass that, and Uncle's going to blame me. Anyway, that's the package. That's the whole brand name, Laser Borosizer. eBay's full of them. If you do this, I suggest get a 5 milliwatt red. I really do. Oops, I forgot the screwdriver that came with it. Hey. You're safe? Okay. And the 50 micron mammography, that's pinhole camera photography, mammography aperture, $11. Paid 10 for this, but so far the prototype I showed you with the Borosizer here and that cheap piece of plastic holding it in, $25. I got reduction in the spot size. I also showed that I needed a larger, more powerful diode. Maybe a diode that has angular confinement to start with. Have to talk to the manufacturers about that when they call me. Anyway, that's the idea. I want to manufacture it, or see it manufactured. Every machine shop in the world wants to put X marks the spot, wants to put that 1,000th of an inch diameter red dot on X marks the spot from 12 inches away. Metric, they may settle for 1,000th of a millimeter. Where's that 100th of a millimeter? That's yeah. I'm more comfortable on inch. Hey, they may want to use different size of laser spot. That's unimportant. Every machine shop in the world wants it. Every one of them out there. All of them. Talk to the YouTube machinist channels. Talk to Adam Booth. Ask Adam Booth, does he want to be able to put where X marks the spot is from 12 inches up, 1,000th of an inch diameter red dot? Ask the Keiths, Fenner, Rucker, Appleton. Keith Appleton? Yeah, he does model steam engines. The Shearline over here, except for the 3-jaw chuck, he'd probably think is a fairly decent machine for small parts. Some of the models he makes, the Shearline's too big. I mean, too small. The parts are too big for the Shearline. Kilroy. I know you want to put that 1,000th of an inch diameter red dot on X marks the spot from 12 inches up. Mr. Barton. Don't you really want put that little red dot here from 12 inches away? I have seen that measuring device with the box over here, and oh, that's 2 millionths. Ah! You want one? I know. Yeah, you. I know you do. Don't lie. Look deep inside yourself. Steve Summers. You want one? Tom Lipton. You want one? I know there are people out there, Starrett stamps their name on it. They'll buy it automatically. First time they use it, they'll love it. Starrett, Absolute Zero. Yeah, that sounds like good advertising already. No. Starrett, Absolute Last Word. Boom. Absolute Last Zero, that would be if it was Mitsubishi. Mitsubishi. You got engineers sitting around the office hoping they don't have to empty trash and scrub toilets for the rest of their career. I know they can come up with 1,000th of an inch diameter red dot from 12 inches away. They can even figure out 1,000th of an inch and 12 inches. If I can't figure out the reciprocals from inch in my head anymore, but that young engineer, he probably can still, anyway. Mitsubishi, Absolute Zero. Everywhere else in the world but in America, during World War II, American fighter pilots hated the Mitsubishi, named the model number, and they called it the Zero. Next year, machinists all over the world are going to love the Mitsubishi, named the model number, Absolute Zero. See? Already got your advertising for you. Mitutoyo. I know it ain't a measuring tool yet. There's some circuitry to add to it so it can actually measure distance. And once you figure out distance, you can go for dimension. That makes it a measuring tool, don't it? I mean, you want to get a hair Starrett in one thing. I mean, and Starrett. You make everything for the machine shop, from hammers, scribers that you take out the point, screw it back in, put it in your pocket, the Starrett pocket scribe. Gauge blocks. Anything that you can do to a micrometer, Starrett does. Every machinist in the world wants to put 1,000th of an inch diameter red dot on X marks the spot from 12 inches away. They do. You know they do. Yes, you do. Are you a young patent lawyer? I know I can't get basic patent on none of this, but there must be a application patent I could get out of this. You guys work on commission? Contact me. Hey, I cut you in. Whoops, you're a lawyer. You'll be cut in all automatically, right? Manufacturers. Someone's going to build this. You be the guy to build it. Be the company that they say, oh, everyone's just copying. Shars. Shars makes a lot of machine shop electronics, like that digital readout I saw one guy on YouTube using the other day. Imagine a plug on the side of it, or outlet for a plug anyway. Plug in the laser, put it in the spindle, put the little red dot where you want it, push the button, turn the laser off, put it in its box, put it in your tool chest. You manufacture, you want to get involved, put a video here on YouTube saying, yeah, we'll get together. Patent lawyer, video, YouTube, we'll get together. YouTube machinists out there, I mention your names. One of you has to say, I want this. Let me in on it somehow. Let's work together and get this made. Now, it's about dinner time, so Poppy is going to sign off for now.